Hello everyone, welcome back to another video. So today we are going to discuss solutions for four problems A to D of round 913 div 3. So let's start with the first question. So in this question we are given a chessboard, a position of a rook in a chessboard. So chessboard, each column is represented by a letter A to H, and each row contains a value. Each row is represented as a number from 1 to 8. So position of this rook in the given example is d5. So we are given the position of the rook and we have to find all the positions where uh, rook can uh, uh, go. So here rook can go in the at any position in the column and at any position in the row. So we have to print all the possible moves for the rook. So it's a very simple implementation problem. I will just show you the code for this. There is no logic behind it, just I have to print all the positions in the current row and current column. So I first take the input as string and store the character C, which is S of 0, which represents the column, and similarly the row integer row number, and for I equal to 1 and less than 8 in each row I can move to uh, D D6, D7, D8, D4, D3, D2, D1. So I am printing this if I is not equal to D, because I don't have to print it again, because I am already at the rook is already at that position and it can't move to the same position again. And similarly for each character from E to H, I'm printing the character and D if the current character and C2 doesn't match. So this was the solution for problem A. Let's see problem B. So in problem B we are given a string S, and whenever so the string represents an input to a laptop keyboard, and whenever B is pressed on the keyboard, it deletes the last rightmost lowercase letter, and if the key uppercase B is pressed, it deletes rightmost uh, B, rightmost uppercase letter, and if there are no such letters it will just ignore the press. And also the B is not added to final string, so we have to print the type string after pressing the all the key presses. So for example, let's take a small example, A, B, B and T. So first it will press A, then it will press a small a, and when it reaches B, it removes the rightmost character which is lowercase before this index. So for lowercase b it will remove this a, and again it will move to next character which is uppercase b, then it will remove this uppercase a, and t will be pressed because there is no condition for any other character other than b. So the output of this final string will be t. So for solving this question we can use two vectors or two set, or probably two sets too. So after reading this question I thought of stack, so I am considering two stacks, one for lowercase letters and one for uppercase letters, and I am also using a map which represents which character if ith character is deleted from the string, it will be the mapping will be of that index to 1, or else it will be 0 as initialized. So whenever an uppercase letter comes, I will push its index in uppercase stack, and whenever lowercase comes I will push it into lowercase stack for lowercase elements, and whenever a lowercase b is represent comes, I will pop the element from lowercase stack and map its index to 1. So here I will just map mp of 1 equal to 1, and also for this index where it is b, I will also map it to 1 because I don't have to use it while printing the final string. And similarly, when an uppercase b comes, I will pop the topmost element from uppercase stack and map it to 1, and also map the current index of b to 1. And finally I will print the characters at which the mapping of that index is 0. So that means it is not popped by any element uh, which comes because there was an uppercase or lowercase b. So let's just see the code for better understanding. So this might be a overkill solution, but I was I came up with this solution as at first glance, so I just wrote the solution. So for each I am iterating towards in the whole string, and if the character is b, I will just mark it 1. The index, I will mark that index with 1, and if the stack is empty, I don't have to perform any operation. So st represents lower stack for lowercase indices, and st2 represents stack for uppercase indices. So if stack is empty, I will just continue, and if it is not, I will make the top of map the top index with 1. So mp of st dot top equal to 1, and pop that index. Similarly, for if SI is capital B, I will do the same thing but for stack 2. And else if it is a lowercase letter, I will push the index in lowercase stack, which is st, and else I will push it to second stack. Now if I will print all the characters whose indices are mapped as 0. So here, as you can see, the indices for t was mapped to 0 because it was not deleted by any of the b's. So final string will be t. So for every character which is not mapped as 1, I will just print this character and endl for each test case. So this was the solution for second question. Let's move on to third. So in third question, uh, we are given a string of consisting n lowercase Latin letters, and we can remove any pair of adjacent characters if they are different. So they have given an example as raccoon, and we can remove ra, so the string becomes CUOON. We can remove EC, the string becomes ROON, and we cannot remove double O because they are adjacent and equal. So RACN cannot be the output, one of the results of this string. So we have to print minimum length Vlad can achieve by applying any number of deletion. So let's see the example first. So first test case is ABC. So we can remove this AB because adjacent elements are different. So the string becomes AC, and then again we can remove this AC, the string becomes empty string. That's why the answer of this is 0. Similarly, let's see this ABAC. So we can remove, let's say, this AB, string becomes ACA, and remove this AC, the string becomes A, and we cannot perform any other operation, so minimum length becomes 1. And so first observation is, if the length of the string is odd, the answer will be at least 1, because um, in each deletion the number of the length of substring gets decreased by 2. So for an odd number, it will become, let's say for 5, after deletion it will become 3, and after that deletion it becomes 1. But when the string length becomes 1, you cannot perform any operation. So for odd length, the at least answer is 1. Similarly, for even length, at least answer can be 0. Now if you see, try to find observations. For example, let's take this test case. Okay, let's just, I will make one test case. Let's say I have an odd even length string AAA and BB. Now if you see, I can always remove this A and this B. Similarly, I can also remove this A and this B, and remaining two A's will remain as it is, because there are no different characters other than A in the string. So from, if you try other solutions, let's say I have AAA and 3 B's. Now I can remove all the steps, all the characters. First I will remove this AP, then this AB, this AB. Now if you do any combination of these strings, for example A, B, then A, B, B, you will always be able to remove all the characters from it by using the add operation given in the problem. So it solely depends on the maximum occurrence of characters. So here the maximum occurrence of 4, and other characters are other different characters are 2. So remaining 2 characters will not get vanished by the performing the operation. So if the maximum occurrence of any character in even length string is, if it is less than equal to n by 2, we can always vanish the whole string. So answer for this case, it becomes 0. Let's say mx is maximum occurrence, and if mx is greater than n by 2, so this was the case where 4 maximum occurrence was 4, and then by 2 with here is 3. So the answer will be maximum occurrence minus the remaining elements n minus mx. So here mx is 4, then there are total 6 elements, out of which different characters are 6 minus 4, which is 2, and 4 minus 2 will become 2. So mx represents maximum occurrence, n minus mx represents all the other characters which are different from the characters which has maximum occurrence. So these two elements will remain, and this is the formula for even length. Similarly, for odd length, if the maximum occurrence is less than equal to, here it will be n plus 1 by 2. Sorry, it will, here also it will be n by 2, because if the characters are, let's say 4 has maximum occurrence and other characters are 3, we can remove only 3 elements and 1 will remain there. So if it is something like this, answer will be 1. Else the same formula works here. 4 minus, let's say total is 7, 7 minus 4, and this will be 1. So this is the solution for third question. A lot of participants found this question difficult. It is, so if we read this question first, thought will be of solving it by stack, by just simulating this solution, but it will not work. And this observation, if you see third case, they have they have purposely given such test case where the occurrence, maximum occurrence is can be seen. For example, here you can see 6 V's are there and the answer is 2. So they have given this for purpose for observing the solution. So if we see its code, It's pretty simple. I'm just storing the occurrence in map and taking the maximum occurrence, storing it in mx, and I have made two cases. If n percent is 2, if n is even and mx is less than equal to n by 2, answer is 0, else answer is mx minus n minus mx. And if n is odd, if mx is less than n by 2, answer will be 1. As we discussed, for odd at least answer is 1, and else it will be mx minus n minus mx. So this was the solution for third question. So next question is jumping through segments. So using this question, it is an range intersection question. So we have to know what is how to take intersection of two ranges, and I will tell you about that in this example. So we have given we have a line, and we are starting from 0, and we are given multiple ranges. L1 to R1 is first range, L2 to R2 is second range, and L3 to R3 also. This is L2 to L3 to R3, and L4 can also be behind L3. So there is no order in this, and we have to follow this order L1 R2 and L2 R2. We cannot skip we cannot skip the segments in between. So we have to go from this 0 to any point in this L1 to R1 in first operation, and in second operation we have to go from this segment to this segment. In third operation we have to go from second segment to third segment, and in third operation we have to in fourth operation we have to go to fourth segment from third segment. Now the condition here given is, if we choose any value k, the maximum distance which we can go is should be less than should be k. So we cannot move, we can only move if the distance is less than equal to k. Now we have to find the minimum value of k such that it is possible to move from 0 coordinate to nth segment. So we have given n segments, and we have to move from 0 to nth segment and we have to calculate the minimum value of k such that it is required. So let's start with how to find. Let's just start with first observation. So first observation is use of binary search. So let's say I move this question itself gives hint of binary search because we have to find minimum value of k. So if we have, let's say, k plus 1 as the jumping strength, let's say distance we can travel k plus 1. So it is possible with k plus 1 if it is possible with k. Similarly, it is possible with k plus 2. Now if it is minimum value which is possible is k, so k minus 1 will be not possible. So it generates a predictive function f, and for k it will be true, and for all the values above k it will be true again. So this gives using this observation we can see it is a problem of binary search on answer question. Now the second part of the question is how to see if k can make if the value of k, is it possible to move from 0 to nth segment, and in each operation we have to move from first segment, second segment, and third segment. So let's just start with first stage. At first stage, initial stage, we are at position 0. So what is our range of initial position range is 0, 0. Here we have to work with range because we cannot store a single number, because possibility of going anywhere here is a range, because from 0 0 I can go to 0 comma k, because this is the possibility of going. If let's say I have k equal to 3, I can move to remain at 0 position, move to 1, move to 2, move to 3. So all the we have to store all the possible solutions uh, which can be possible. So we can move from 0 to k. Now in first segment we have to move, we have to be in L1 to R1. So what are the possible points at which we can be after first segment? It will be equal to intersection of these two ranges, 0 to k and R1, L1 to R1. Now let's say I get an intersection x1 y1. Now for second segment L2 R2, what are the possible ways of x1 and y1? It is equal to x1 minus k plus y1 plus k. So this is the possible distance which I can cover in second segment, second operation. And similarly I have to go to R2, between L2 to R2. So for this I have to take intersection of these two elements. Similarly, let's say the intersection comes out to be x2 y2. Then again my possible distance is, possible distance which I can cover is x2 minus k and y2 plus k, and I have to take its intersection to with L3 and R3. I have to keep doing this until n, but whenever this intersection doesn't have any common point, we cannot, uh, means we cannot cover the whole segment with this current k value. And if current k value fails, gives us false, we move to next, we just make the windows, make the binary search window after k, after the value of k, to whatever high was it was before that. High and low just means the binary search window. And if it is true, there might be a possible value before it. So when it will be true, when it will process all the n segments and there was intersection point until the last segment. So this will be the new window for binary search, which is low to basically k. So let's see the code. And for intersection, for calculating intersection, there is a simple formula. Let's say I have two pairs AB. A represents first range and it is a pair of two integers, and B is also a pair of integers. So let's say this is the first range, this is a1 dot f, a1 dot s, and this is b1 dot f and b dot s. So intersection becomes this part. So we have to final output of this intersection B should be b1 dot f comma a1 dot s. Now how to calculate this from this? It is very simple formula. So left side of our intersection is maximum of both the left sides of these two pairs. So max of a1 dot f comma b1 dot f, and the right side becomes minimum of both the right sides of uh, given ranges. So minimum of a1 dot f, a1 dot s and b1 dot s. Now how to check if there are no intersections? So when we take max and min, if the first, let's say this is answer, so answer range. So if answer dot first becomes greater than answer dot second, that means there are no range. So let's say this example, so this is a1 dot f, a1 dot s, and this is here, as you can see the first will become this point in the answer and second will become this point, but this is, let's say, f and here s. Here in the range f is greater than s, and it it is because there was no intersection. Here there was gap, and that's why there is no intersection. So we can find this by just adding this checker at the end of each intersection. So let me just show you the code. So I am first storing it in an vector, and the minimum value of k can be a of 0 dot first, because it will be the first distance which we travel, and we will just iterate. We will This is an binary search for loop, and will count k will be the sum of low and high divided by 2. And first I am storing the current position as 0 0, and if a of I dot first greater than current dot first, so this just checks if it is forward. The next we have to go forward or backward, but this is not necessary. I can just this is not necessary. uh, Both the conditions, the operations in which we are considering, both are same, so this is not necessary. So I will make current dot first minus equal to k, so this intersection x1 minus k and y1 plus k, and current dot second plus equal to k. But if the current dot first becomes minus, it goes into minus, so I will just consider it as 0, because there is no mentioning about negative segments, negative points on x-axis. And then take the intersection of current pair and a of I. So in intersection I have declared a function called as iset, which returns a pair, and pair or LL answer is max of a dot first b dot first and minimum of a dot second b dot second, as we discussed earlier. And I am just checking this. If the current dot first becomes greater than current dot second, I will just make found equal to false and break the for loop, and I am declaring found true at each iteration in binary search loop. So if found is true, then answer is k. I am storing the answer. High becomes k minus 1, else low becomes k plus 1, and I am just printing answer at the end. So this was the solution of D, and I will also make solutions for E and F, but in separate video, or else this video will become very long. And thank you for watching.